Let's explore on integration using substitution. Right? Let's look at example 4 on page 37. What was given? You are required to use the substitution of u equals to 2x minus 3 to determine the integral of 56x 2x minus 3 to the power of 5 with respect to x. When we talk about substitution, we meant to change all the x term into u terms. And given to you the substitution of u equals to 2x minus 3, differentiating u with respect to x will give you 2. So what should we do next? Should be rewriting 56x 2x minus 3 to the power of 5 dx to the form of u. And how do we convert this? 56 is just a number, so take it as it is. X is to be converted into u. And how are we supposed to do that? Let's do this on the side. U is equals to 2x minus 3. If I were to rearrange, I should be expecting to get x equals to u plus 3 divided by 2. Hence, u plus 3 divided by 2 is what you plug there. What about x minus 3 to the power 5? This should simply be u to the power 5. What then is with dx? Check this out. Du over dx is equivalent to 2. If I were to rearrange this, I should be getting dx equals to du over 2. Substitute dx to be du over 2. You will have the whole integral in the form of u. Simplifying this would give you u plus 3 u to the power 5 du. Open brackets accordingly. I should get 14 u to the power of 6 plus 3 u to the power of 5. I'm supposed to integrate this with respect to u. What would I get next? 14 is just a number, copy as it is. Integrating u to the power of 6 would give you u to the power of 7 over 7. And integrating 3u to the power of 5 would give you 3u to the power of 6 over 6 plus c. Do we leave our answer like this? Of course no. And how should we actually write our answer? You will have to write it back in the form of x, because question given was in x and hence you are expected to present your answer in the form of x. Let's do a little bit of simplification before we change u terms back into x terms. This should be 2x minus 3 to the power of 7 plus 7, 2x minus 3 to the power of 6 plus c. Get another example. Example 2 on page 38. We are required to find the integral of sine ln 2x over 2x dx. There wouldn't be any formula that you can use in order to solve this integral, hence substitution would be the last resort. What is the right substitution? We usually take things that are in bracket as the substitution. Hence, for this case, u is equals to ln 2x. What is du over dx? It is simply 2 over 2x. And how did I get this? I got it by using the formula of d over dx ln fx equivalent to f prime x over fx. This is something you have learned with methods. Okay. So looking at this one, obviously 2x is fx, and hence I would be expected to get fx as the denominator, and hence differentiating 2x give me 2, and that would serve as f prime x. What should I do next? Simplify du over 2 dx, and I should be seeing 1 over x. Substitution simply means changing all x terms into u terms. So what should I do? You will have to change all x terms into u terms, and hence I should be getting sine u over 2x and dx. What is dx? If I were to rearrange du over dx equals to 1 over x, I should be expected to write dx to be x du. So what do I substitute over here? I got to be plugging x du accordingly. We are still not done eliminating x, substituting x. Therefore, x that I see here and x that I see there can be cancelled out, and hence I should be getting half integral of sine u du. What do I get when I integrate sine u? It should be simply negative cos u, and I should be getting negative half cos u plus c. Again, this shouldn't be my final answer, as I was given a question in x, and therefore my final answer would be negative half cos ln 2x plus c. Moving on, let's look at integrating sine to the power of 5x cos squared x respect to x. This is an example taken on page 39. The question is, can I be using this formula? The answer is no. Why is that? If I were to look at sine to the power of 5x cos x dx, no issue to use this. Reason being, the part that is with power should be taken as fx, and therefore for this case it would be fx to the power of 5 equals to sine to the power of 5x. What do I get if I were to differentiate sine x? I would be getting cos x, and it is exactly that. So what would the answer be for such a question? I should be getting fx to the power of 6 over 6 plus c, and answer would be sine to the power of 6x over 6 plus c. How is this question different from that? There's an additional power. So what then should I do? Like what I told you earlier, if you cannot solve an integral by using formula, you will need to work on substitution method. But the question is, what do I substitute? We should let u to be cos x. Right, continuing from the previous slide, we are trying to solve the integral of sine x to the power of 5 cos square x dx. And I mentioned to you earlier to use the substitution of u equals to cos x. And why is that? Let's explore on, and you will see the reason behind. If I were to let u to be cos x, I will need to have as many cos x as possible in the integral given. Hence, I will be rewriting sine to the power of 5x cos square x to the form of sine square x sine square x sine x cos square x. How then should I be converting square x sine square x into cos x? I'll be using the identity of sine square x plus cos square x equals to 1. Hence, sine square x is simply 1 minus cos square x. What should I get next? 1 minus cos square x, 1 minus cos square x, cos square x, sine x dx. Open brackets accordingly, or perhaps there's no need to open brackets, just change this cos x into u. You should see 1 minus u square, 1 minus u square, sine x dx. Our job now is to convert sine x dx into the form of u. And how can I do that? Look at this again. If I were to rearrange, I should get du equals to negative sine x dx. And since sine x dx is what I wanted to change into u, I would be writing sine x dx equals to negative du. Hence, next step would be 1 minus u square, 1 minus u square, negative du. And I have successfully converted all x terms into u terms. Simplifying this would give you negative u square minus 2 u to the power of 4 plus u to the power of 6 du integrate this should give you negative u to the power of 3 plus 2u to the power of 5 over 5 minus u to the power of 7 over 7 plus c. Again, answer must be in the form of x, hence you are expected to write negative cos cube x over 3 plus 2 cos to the power of 5x over 5 minus cos to the power of 7x over 7 plus c. So what do you realize in the previous slide? It is integration of sine to the power of 5x cos square x respect to x, and we have let u to be equivalent to cos x. Why did I do that? I see two powers, one being odd and another being even. I have taken substitution with the power that is even. So what then do you think you should do if you were to be solving the integral of sine square x cos to the power of 5x dx? Even power is with sine x this round, and odd power is with cos x. So what would your guess be as the substitution for this question? It should be u equals to sine x. Alright, so let's look at this one, sine square x cos to the power of 5x dx. So what was it that I told you earlier? You should be letting u to be equivalent to sine x. If you were to differentiate this u with respect to x, that is when you will get cos x. So substitution method simply means changing all x terms into u terms, hence you are expected to change sine x into u. In order to do that, you will have to rewrite cos to the power of 5x into cos square x, and cos x. Right? So what is next that I got to do? I must be seeing as many sine square x as possible. Hence, I will be converting cos square x into the form of sine square x, and I'll do the same with the rest. Right? So what are we supposed to do next? Substitution is what we are doing over here. Sine x is to be changed into u, hence sine square x will give you u square. 1 minus sine square x will give you 1 minus u square, and this would also be 1 minus u square. And what then is cos x dx? Leave it as it is, and we shall see how we can change it. If you were to rearrange du over dx equals to cos x, you should be getting du equals to cos x dx. So what do I plug over here would be integral u square 1 minus u square 1 minus u square, and this should be du. Simplifying your integral, you are expected to write integral of u square minus 2u to the power of 4 plus u to the power of 6, and you got to simply integrate this u expression with respect to u. What would you get next? Should be u to the power of 3 over 3 minus 2u to the power of 5 over 5 plus u to the power of 7 over 7 plus c. Again, we are given a question that is in the form of x, hence answer must be in the form of x, and you are expected to write sine to the power of 3x over 3 minus 2 sine to the power of 5x over 5 plus sine to the power of 7x over 7 plus c. Alright, so we have learned sine, integrating sine to the power of mx, cos to the power of nx respect to x. If m is odd and n is even, we have to be substituting, or we have to let u to be equivalent to cos x. And if you were to look at again sine to the power of mx, cos to the power of nx dx, if m is now even and n is odd, we have to let u to be sine x. This is something I would like you to ponder upon. What happened if I were to have both m and n to be odd, and what if m and n are both even? What substitution do you think we should be using? Think about this, and I shall tell you the answer when I see it. These are the tasks that you will have to complete. Example 6 on page 41. Exercise E and F, odd numbered questions. Enjoy exploring integration. Bye.